In this problem, we will use both heating and cooling curves to determine the initial mass of boiling water needed to reach a certain final temperature. First, we draw the heating curve of the ice and the cooling curve of the boiling water. Next, we find the moles of ice by dividing the mass present by the molar mass of water. Now, the first part of the heating curve is the heating of the ice. Using the mass, specific heat of ice, and the positive change in temperature, we can find the energy needed to raise the temperature of ice to its melting point. In the second section, we use the heat of fusion to calculate the energy needed to melt 1.39 moles of ice. Finally, in the third part, we can find the energy needed to raise the temperature of water to the final temperature of 45 degrees. Adding these energies together, we obtain the total energy needed to convert ice at -3 degrees Celsius to liquid water at 45 degrees Celsius. Now, because no energy is added or removed from the system, we know that the energy released by the cooling of the boiling water must exactly equal the energy absorbed by the ice. In this way, we can find the initial mass of boiling water needed. Note that the 13,200 joules is negative because the heat released by the water and not absorbed by the ice should add to 0. Solving for the initial mass, we see that the answer is 57.5 grams. While we have already used heating and cooling curves to determine final conditions, in this problem we worked backwards to calculate initial conditions using the fact that no energy is gained or lost in the system.